Okay, so a triangle exists if the sum of the two smaller sides is larger than the third side. Okay, so that's great. Words are awesome. Gag me. But in a picture, it makes a whole lot of sense. Okay, so let's draw a little triangle here. I'm going to draw a little triangle. Here we go. This is the base of my triangle. And the base of my triangle, I'm going to say is 9 units long. Okay, 9 units long. And let's see. I'm going to draw, all right. This side of my triangle is a side length of 4. And this side of my triangle, the third side here, is a side length of 5. You'll notice I didn't connect them because I'm going to ask you, think of those as sticks, okay? And you've got 3 sticks. One is like 9 inches long, and one is 4 inches long, and one is 5. Would those sticks hold each other up with like a roof?
No.
Why not?
No,
Yes.
they wouldn't because they equal the bottom, so it's not going to be enough to keep it up.
Right, exactly. It's not going to be enough to keep it up. The 4 and the 5 would just fall straight down and lay flat on top of the 9, dead even. Right? We can't have a roof because they're exactly the same.
Oh.
Does that make sense?
Yeah.
Okay. 10 or higher?
Or 9 or higher.
Not higher than 9. So like 9.0001, and we'd have a little baby roof, okay? All right, so what about if I have a base of, say, 9, and I have a side length of 5 and a side length of 3? Is that going to form a triangle?
Yes.
5 plus 3 is not greater than 9.
So these two pieces won't touch each other, will they? Okay, they won't touch each other. So yeah, that 3 is just going to fall flat down. That 5 is going to fall flat down. There's going to be a gap, right? Okay. So the 2 smaller sides always have to be just a little bit larger than the third. So we're going to do a couple of these. Determine if the following side lengths could form a triangle. Prove your answer with an inequality. So what are my 2 smaller sides? 8 and 17. So 8 plus 17, is it greater than 24? True or false?
True.
True, it is. Why?
1 by 1.
Yeah, 8 plus 17 is 25. So it is 25 is greater than 24. So yes, it forms a triangle. What about number 2? What are our 2 small sides?
3 and 3 with 6.
3 and 3. Is it greater than 7?
No.
No, that is false. Would you please make this a correct statement? So we're going to go ahead and do a slash through that greater than sign. That, of course, tells us it is not greater than. All right, so that is a false statement. This does not have a triangle. That can't be a triangle. What about number 3?
Yes.
What are our 2 small sides?
25 and 12.
25 plus 12. Is it greater than the third side? True or false?
True.
True. Do we all agree? Yeah? Okay, 25 and 12 is?
37.
37. Okay, so yes, that makes the triangle. What about number 5? Why? What's 50? 28 plus 22. Is it greater than the third side? Is 50 greater than 50?
No.
No, that is a false statement. It is not. This does not have, cannot possibly be a triangle. Okay. Questions on that? Is it like the easiest thing ever? Pretty much, yeah? Okay. All right, so we can also use this information to talk about how to find the range for the third side, to figure out what are all the possible side lengths that we could have and form a triangle. And so what I'm going to do is, again, with a little example here, I'm going to draw a little triangle, and I have the base, I'm going to say it's 11 units long. And then I'm going to draw my second side, and I'm going to say that that's 3 units long. I want to know what is the shortest possible side that this could possibly be, this third side. What is that length? What could it be? Can it be 8? I love that you said 8. How did you get 8? You subtracted 3 from 11, so 11 minus 3 is 8. Okay. Can it be 8?
No.
No. But what would work?
8.1.
8.1 or 8.0001, yeah. So if this is slightly bigger than 8, that would be fine. So slightly bigger than 8, that'll form a triangle because 3 plus slightly bigger than 8 is greater than 11. Okay? Does that make sense to you? And how did we get 8? 11 minus 3? Okay, so we just did the difference. All we had to do is subtract. Okay. Now, if I rearrange this triangle, let's say I'm going to have a side of 11 again. But now I want to find the longest possible side length that I could have. So I'm going to swing my 3 arm. All right, I'm going to take this 3, and I'm going to swing it so that I make my triangle as wide as I possibly can. It's going to be a really funny looking triangle, okay? So if I swing that 3 arm and swing it as wide as I possibly could, again, what would this third side be? Would 14.01 work? What happens at 14? Is it a triangle anymore, or is it a flat? It's gone flat, hasn't it? Yeah. Well, it actually has to be slightly less than, right? Less than 14.0. If it's 14, our triangle is laying flat open. Okay, do you see that? Can you visualize that? Okay, so our triangle at 14 would be laying flat open. Now, if we pull that side 14 up just a little bit, let's shrink that side 14 down just a tiny, tiny bit. Now we have a little bit of a triangle action going on. Yeah, 13.99999, absolutely. So as long as it's slightly smaller than, how did we get 14? You added them together, okay? So all we have to do is figure out the sum and difference, and that's going to give us our range of possible values for a third side. We're going to let x be the third side. We're going to put that in the middle for our inequality, and we're going to say, hey, I want the difference. That's always going to be the smallest number. And then we put the sum, S is for sum, and that's going to give us our biggest possible side lengths, okay? So given 2 sides of a triangle, you can set up an inequality using the sum and difference to show a range of possible side lengths. So we have 2 sides here, and all I have to do is figure out the difference and figure out the sum. What's the difference? 22 minus 14 is 8. And what's the sum? 14 plus 22? 36. Can you do that in your head, maybe? Yeah, maybe. Okay. And that's fine. We're writing it down because this is notes. This is a good place to write everything down in notes, right? So you can look back later. So I want to write the inequality. So I want my third side to be greater than 8. And it needs to be less than 36. So this is our range of possible side lengths for the third side. Just like the picture that we did here, we went from between 8 and 14. Okay? Same idea. Number 10 here, what's the difference? 3. 31 minus 28 is 3. And what's the sum? 59, okay. And so for our inequality, our third side can be greater than 3 and less than 59. Now, I do want to tell you right now, I'm going to caution you, you have to write it this way, okay? It is incredibly wrong to write the 59 over here.
Is that an order of operations?
Well, this says, well, Yeah. This says that 59 is smaller than 3, essentially. Is that a true or false statement? Yeah, it's totally false. So definitely make sure that you're doing it the right way. It's also... Yeah, I'll just leave it at that. Okay, any questions on these two? Sum and difference, pretty easy, yeah? All right, let's look at 15 real fast. Given the two of the side lengths, check all the possible side lengths. So this is the same thing. We want to find our sum and difference. What's our difference? 27 minus 15 is 12. That was so fast. All right, well, what's our sum? 27 plus 15.
42.
I'm going with 42.
Yeah.
All right, so we have our third side. That's got to be greater than 12 and less than 42. So 34? Yeah?
Yeah.
12? No. 29?
Sure.
Yes. 18?
Yep.
Yes. 43?
Yep.
No. Okay. Questions on those?
I'm kidding.
Am I going too fast or too slow?
I'm good.
Good?
Too slow.
Too slow? All right, let's turn the page. And it gets easier still, ladies and gentlemen. Easier still. Ordering angles and ordering sides. Totally easy, totally logical here. Makes perfect sense. The angles of a triangle can be put in order by comparing the sides. The smallest angle is always opposite the smallest side. The smallest angle is always opposite the smallest side. The largest angle is always opposite the largest side. Super easy. It makes perfect sense. When you think about this triangle, my angle looks very small because the side opposite is short. Right? If that side were forced to be longer, then my angle would have to open up to accommodate it. Does that make sense to you? All right. So here I have my smallest side, and that's going to be opposite the smallest angle every single time. So we want to order the angles from least to greatest. What's the smallest angle? Ooh, that's a side. Whoa. Angle A. Very good. What's the next smallest angle? C. Angle C. What's the biggest angle?
B.
Angle B. We got our biggest side at 13. That's going to be opposite the biggest angle. Okay. Questions on that? Do 17. Order the angle measures from least to greatest. All right, what's the smallest angle?
M.
Angle M. What's the second one?
P.
Angle P. What's the biggest one?
N.
Angle N. Very good. Meh. All right. Questions on that? Super easy, right? So easy. All right. Now, this is exactly the same thing. The sides of a triangle can be put in order by comparing the angles. Vice versa. The smallest side is opposite the smallest angle. And the largest side is opposite the largest angle. I don't know why she separated these two things, but whatever. So I want to order these side lengths from least to greatest. And be careful, we're ordering sides. All right, order the sides. What do I need to do with this triangle before I can do that? Solve for the measure of angle F. How do we find the measure of angle F? Add them up and subtract from 180. So I'm going to do 180 minus 42 minus 103. And what do we get? Good. 35 degrees there for angle F. All right. So now I have my smallest angle. What's my smallest side? ED. Very good. Right there is my smallest side. So ED, segment ED. What's the next side?
DF.
DF. What's the longest side?
DF.
EF. Very good. Biggest angle, biggest side. Okay. Makes total sense. Will you do 21? Order the side lengths from least to greatest. Number 21. Do number 21. All right, what's the measure of angle K? 92 degrees. What is our smallest side? KL. What is the second side? JK. And the third side?
LJ.
LJ or JL. I'm going to do JL, but yes, either one works. All right, ladies and gentlemen, do you have questions for me? All right. You will want your notes out, okay? You will need them for Delta Math. So have them handy, and you can work on the Delta Math assignment.